Hello students, in previous lecture we have studied about the test for parallel lines, that is interior angle test, corresponding angle test and alternate angle test. Those theorems are useful to prove the few more properties which is related with the parallel lines. That means today we are going to study about the application of those theorems, that is test for parallel lines. Today we are going to prove one more property, that is, see here, if line perpendicular to two distinct lines in a plane, lies in a plane, that is in the same plane, then those lines are parallel to each other. That means suppose there are two different lines in the same plane. See here, H is a plane in which those two lines are there, line L and line M. And if there is one more line which is perpendicular to the line N, which is perpendicular to the line N, as well as that line N is also perpendicular to the line M, and those two distinct lines lies in the same plane, then those two lines are parallel to each other. We have to prove that those two lines are parallel to each other. For this proof, we have to use the test for parallel lines. Then, first of all, we have to draw the figure for it. Then see here, there is a line perpendicular to two distinct lines. That means, see here, there is a line N which is perpendicular to line L, as well as that same line which is perpendicular to line M also, and line L and M which lies in the same plane. Then we have to prove that those two lines are parallel to each other. Then see here, we have to label this angle A, here B, angle B, angle C and angle D. Then here given that line L and line M are two distinct lines, and which lies in same plane. That means those are lies in same plane. Line L and M lies in the same plane, and here the line N which is perpendicular to the line L, as well as line N is also perpendicular to line M. Then we have to prove the property, that is here line L parallel line M. Then for this theorem we have to use the test for parallel lines. Then see here, proof is given here by direct method using the interior angle test or corresponding angle test, or alternate angle test. Here we have to use the corresponding angle test to prove this theorem. Then see here, in the given, line L and line M are two distinct lines, and here line N perpendicular to line L, that means here line N perpendicular to line L. Therefore here angle A is equals to 90 degree. That is given, as well as line N perpendicular to line M. Here line N perpendicular to line M, that is also given. Therefore here angle C is also 90 degree. Then see here, as angle A and angle C are 90 degree, therefore here angle A is equals to angle C. And see here, angle A and angle C, those two angles are congruent. Then see here, line N is a transversal of line L and line M. Angle A and angle C are corresponding angles. Here angle A and angle C are corresponding angles. Angle A and angle C are corresponding angles. And those angles are congruent. Therefore line L parallel to line M. Therefore line L parallel to line M, because property of corresponding angle test. Then there are few examples which is based on those properties or theorem which is given in the practice set 2.2. Then here we have to solve those examples. Then see here, practice set 2.2, question number 1. Here example is given, that is the figure is given, that in which here line M and line N, two lines are given here, whereas line L which intersects to those lines into different points, that is point P and point Q. And here angle X and angle Y is given, that is see here, line L is a transversal of line M and line N, and here line L intersect line M and line N at point P and point Q respectively. Here we don't know those two lines are parallel or not. Therefore we have to justify here those two lines are parallel or not. Then see here angle X is given, that is of 71 degree, and angle Y is given is of 108 degree, that is angle Y is given here, that is 108 degree, and angle X is given here 71 degree. Then we have to determine whether line M and line N are parallel or not. Then see here, line L which intersects to the line M and N in two distinct points, therefore line L is a transversal, and therefore here angle formed is angle X and angle Y, and here angle X and angle Y are interior angles. Interior angles. Then see here, the sum of those two angles, that is angle X plus angle Y, is equals to 71 degree plus 108 degree. Therefore here angle X plus angle Y is equals to here 179 degree. That means here angle X and angle Y are not supplementary. That means here angle X plus angle Y is not equals to 180 degree. Therefore angle X and angle Y are not supplementary. And here interior angle formed by transversal L on line M and line N are not supplementary. Therefore here line M and line N are not parallel to each other. That is the proof of the example given in the question number 1. Then we have to solve the question number 4. That is the example which is given in the question number 4, which is based on the parallel line test, that is interior angle test, corresponding angle test, and alternate angle test. See here in question number 4, the figure which is given here, in which the ray BA and here one more ray, that is ray DE, that is which are parallel to each other. See here in this figure, ray BA parallel to ray DE, and here the angle EDC is given, that is of 100 degree. Here 100 degree, as well as here angle which is given here, that is angle BCD. Angle BCD is given here, that is of 50 degree. Then we have to find out the angle ABC. Then find out the measurement of angle ABC. Then for this purpose we have to do some construction here. Then we have to draw the line parallel to AB, which is passing through the point C, See here line LM is drawn parallel to line AB, which is passing through point C. Then here construction which is done here, that is draw line LM parallel to ray BA, which passing through point AC, that is point C. Then we have to find out the measurement of angle ABC. Then see here, from construction, that is line here LM parallel to line or ray BA. Therefore, proof is given here, that is line LM parallel to ray BA. Let this equation 1. Then here ray BA parallel to, given here, ray BA parallel to ray D, which is given. See here, ray BA parallel to ray D, which is given. Then let this equation number 2. Then see, from equation 1 and 2, LM line which is parallel to BA, ray BA, and ray BA parallel to ray DE. Therefore, from equation 1 and 2, here line LM parallel to ray BA parallel to ray DE. Then we have to use the test for parallel lines. Then see here, DE parallel to LM. Here ray DE parallel to line LM, and here transversal which is considered here, that is DC, and DC is a transversal. Therefore, here this angle plus this angle, that means here angle EDC plus angle DCM. Angle DCM is equals to 180 degree, because those are interior angles. Therefore, here angle EDC is 100 degree plus angle DCM is equals to 180 degree. Therefore, here angle DCM is equals to 180 minus 100. Therefore, here we get 80 degree. That is angle DCM is equals to 80 degree. But here angle LCB, this angle, plus angle BCD plus angle DCM is 180 degree, because those are linear pair of angles. Angle LCB plus angle BCD plus angle DCM is equals to 180 degree. That is linear pair of angles. But here angle BCD, that is here angle BCD, which is of 50 degree, plus angle DCM, it is of 80 degree. Angle DCM is 80 degree. Therefore, here 80 degree plus angle LCB is equals to 180 degree. And therefore, angle LCB is equals to 180 minus 80 minus 50 degree. Therefore, angle LCB is equals to 50 degree. That means, see here, that angle becomes 50 degree. Now, ray AB parallel to line LM, and here transversal BC, transversal BC is considered. Then this angle ABC and angle LCB are interior angles. Therefore here angle ABC plus angle LCB is equals to 180 degree. But here angle LCB is 50 degree. Therefore angle ABC plus 50 degree is equals to 180 degree. Therefore here angle ABC is equals to 180 degree minus 50 degree. That is here angle ABC is equals to 130 degree. That is this angle is 130 degree. That is the example which is given in the question number 4. Then one more example which is given here, that is in question number 5. See here in question number 5 the figure is given this, and here ray AE parallel to ray BD which is given here, and here the ray AF which is a bisector of angle EAB, and here therefore angle EAF plus is equals to angle FAB, that is equals to x degree, as well as here ray BC is an angle bisector of angle ABD and therefore here angle ABC and angle DBC, angle ABC is equals to angle DBC is equals to y degree. Then we have to prove that here AF parallel to BC. Then we have to prove that ray AF parallel to ray BC. Then see here the given, that is ray AE parallel to ray BD. Then see here the proof is given by direct method using test for parallel lines. Then ray AE parallel to ray BD, and here ray AE parallel to ray BD, and AB is a transversal and AB is a transversal. Therefore here see this angle and angle ABD and angle EAB here, therefore angle EAB congruent angle ABD, because those are alternate angles. Then see here EAB B, which is made up of two angles. Therefore, here angle EAF. Angle EAB is made up of, that is angle EAF plus angle BAF. BAF is equals to angle ABD. It is made up of two angles, angle ABC plus angle DBC. Angle ABC plus angle DBC. But EAF, that is a x degree plus BF is x degree, is equals to ABC is y degree and DBC is also y degree. See here. Therefore, angle EAB is 2x degree. 2x is equals to 2y. Then here 2 get cancelled. Therefore, here we get x is equals to y. Then here, but x is a angle. Here FAB is a angle which having measurement x degree. Then here x is equals to y. Therefore, x is a measurement of angle FAB. FAB is equals to, and y is a measurement of angle CBA. Angle CBA. See here, and see here, if angle, those angles, we have to only focus on those two angles. Then when angle FAB now congruent with angle ABC or CBA, then if those two angles are congruent and here those two angles are alternate angles, therefore here line or ray AF parallel to ray BC by alternate angle test. Here angle FAB and angle CBA are alternate angles. Alternate angles, and therefore here ray AF parallel ray BC. It is because of alternate angle test. Alternate angle test. Then that is the proof of example number 5 from practice set 2.2. That type of few examples are given in the practice set 2.2. You have to solve the remaining all examples as well as those solved examples in your textbook. Thank you.